Hey, welcome back, pilots, to the channel. Today, we're starting the brand new series, the 3D print series, that I wanted to start. So the first component we're going to be 3D printing is the Flywing gear replacement. And the first filament we're going to go with is PETG carbon fiber. This is on the more affordable and the lower kind of tier of carbon fiber reinforced filament. Is above PLA carbon fiber, and I'll explain why I didn't start there. And it's for personal reasons too, and test result reasons. And another disclaimer, the Flywing gear is, the STL file is online for free, and the creator did a hell of a job making this piece, so thank you very much. And then I'm only gonna tweak his filament kind of infills and stuff and design just a tad bit. It's more of a preference, and I think it's going to give it a little bit more strength so this test will survive. So let's get into the product that we're reviewing. And on top of that, another disclaimer, I am not a Bamboo affiliate partner or anything like that. I do not get paid. I just have their products, and the 3D filament was on sale. I go with really good brands that go on sale. I don't ever pay full price. That's just me personally. So further ado, let's get into it. So the reason why I picked PETG carbon fiber over PLA carbon fiber is because it has a higher temperature resistance, and I'll show that later in the video. But it was mostly for mechanical properties, more improved on that one. And and a gear is that reason, so it's kind of mechanical. So if anything had like a mechanical, was used for mechanical properties or had a good strength for that, that filament got picked because it's a gear. So it is AMS compatible, which means this is a multicolor filament chamber that changes filaments. That's all that really means. And it's currently on sale. If you buy 15% off when you buy 4, but I think it is on sale for like 10% off for their Black Friday deal. So this site's not currently accurate on what they're saying. So when you're getting carbon fiber, you need to upgrade your nozzle and the extruder gears to hardened steel or metal, because carbon fiber is very strong and it degrades like plastic components really quickly. And a stainless steel will get clogged. A hardened steel will not get clogged, but over time you will need to replace it due to the carbon fiber being so degrading to that material. So the reason why I picked the Bamboo carbon fiber is because I saw drone parts, racing, and functional, highly performed parts with increased impact strength and improved strength. So this is pretty much saying carbon fiber with PETG is better than regular PETG. And this is less clogging and stringing, which I do personally can say by doing a couple of different prints. I hate PETG with a passion because of this and its pain in the booty. But after printing with carbon fiber, I actually like it because you don't have that problem right here. So I could say this, if I ever have to buy PETG, it's only going to be carbon fiber. I will not get the standard. I'm just, it's turned me off the wrong way. So this is just going over the surfaces and like what it's going to come out of and some close-ups and stuff. So also gives me a nice graph of showing like the impacts and the z-axis and all that. And like, because you know, if you crash, your gear usually gets tore up, and if it crashes, maybe the gear will actually survive, because you know that's the most important piece for a helicopter. When it's sold out, you're pretty much, your helicopter's grounded. So I like some of the results, but this is mostly best versus regular PETG, so keep that in mind. So this part right here, they're just telling you the difference from PLA, carbon fiber, and PETG. You can see right here, PLA does have better strength in the X than PETG. This is even better, but I was more focused on the layer adhesion strength, impact strength is higher here, and the heat resistance is higher. So that was pretty much my deciding factor, because if you leave PLA in the car, it will melt even with carbon fiber, or will deform, and PETG has a higher temperature tolerance. And depending on your climate, it's going to dictate what kind of filament you're going to use. And carbon fiber is very hyperscopic, so it does absorb water, and that will degrade your strength of your print if you do not get that water out. So use a dryer or a oven, or you can use a 3D printer that like Bamboo has. You can pretty much put it in the oven itself. You just dry it out. So this is just testing the flexibility that they do. Shows that right there. The requirements, hardened steel, that's what Bamboo recommends. So you can do different types of millimeter nozzles. Here's their colors. The RFID, this is actually really I like this idea. I hope other companies do this, but this actually pretty much gives you all the information of that filament, and it gives you the pre-settings that they test in the facility that gave them a lot of successful prints. And you can always tweak those settings for your settings, so just keep that in mind. It's just a good starting base, which will give you a high success rate in a lot of your prints. And you don't have to try to figure out what's going on with the heat, flow rate, and all that. So like I said earlier, you got to dry it, temperature range, and print speeds. And this is all fed in to that RFID. So, but for me, I tweaked it a little bit on my slicer. So further ado, let's go to the slicer, and we'll send this print to the printer. Okay, so we are in the slicer, so I'm not going to go fully in detail on this. There are other people out there that have explained this whole program better than I ever could, so I will defer to that. I'm just going to show you what kind of settings I like to use. These are just my personal preference. So when you upload the file, that's for free. It does have a lot of parameters already set for you, and it gives a description of what you need to do if your printer doesn't fill that information in. One of his requirements is to do the strength, the infill. So we go to strength. So your infill density is how much is pretty much being print inside. So I'm going to slice and show you. He says 50%, so that's where I'm going to start is 50%. So the higher the infill density is, the stronger your material is going to be. Usually in the 3D print world, we don't really go above 15 to 20. Because most prints, it has a lot of strength. So if I slice it, zoom in, this is the infill. Right here. This is what's going to give it strength. So also your pattern is going to make a difference. Usually they have this rectangular. I like gyro because it's used for like printing like, what's that thing called? Brakes and all that stuff. And it has increased strength, but it also does a good job at reducing heat. So that's what I like about gyro. I have never had an issue with it. In all my print files, I always select this. I think it's just great. Now, that's just personal preference. You may have a different one, so it's totally up to you. Now, the wall thickness, usually the default is 2. I just bump it up to 3, and that's just your outer, and it kind of gives that gear, this part a little bit more strength, because I don't want it to break off if it's weak. So that's why I kind of increase this. And that is pretty much it. That is pretty much what I've changed. The speed, the RFID is going to determine that. But me personally, I just reduce every speed down. So I can, and I think I was just based off of ASA, because ASA you kind of want to print slowly. And it doesn't hurt. So just keep that in mind. And then since it is a Bamboo, this is what I mean when you have that RFID chip. It reads everything, has your flow rate, tells you your diameter, nozzle temperature, cooling, cool plate, all of the information you need. This I'm not going to mess with. Your fan is at 0, so it knows like, hey, I don't need to cool this off, and that's what I want. Okay, so when that's all said and done, you got all your settings. You just go to print, and then you have your printer, and then you just say, hey, I'm gonna turn this off. I'm gonna show you this. So any carbon fiber, it's gonna tell you this, hey, this is very brittle, and it could get jammed up in your AMS. It is AMS compatible. Just keep that in mind. You might have to, some filaments will not be compatible. Just keep that in mind. and then you just hit confirm, and then you just send it to the printer. So further ado, I'm gonna send this to the printer, and we're gonna review the part after it's done. Hey guys, welcome back. The gear is finally finished and it looks great. Now there is a couple tiny little issues I noticed on the gear. It just didn't fill in on certain layers, but I'm actually okay with that. I did print a second one and it kind of has the same issue. So that could be just a temperature issue, which is I could just increase the temperature or increase the flow rate to see if I can fill those gaps in. But overall, that's the only issue I've seen in this gear. Even the metal piece fits in perfectly. And I feel confident of going to the testing phase. And also the reason this is why we put 50% infill to give it more strength if something is a little off. And I would say this, your first layer is always going to be the most important layer, because that's going to determine a success or a failure in your print. And I know there's some other lot more better experienced 3D printers out there that may agree and disagree on me on that one, and that's fine, but that's just from my experience. And then if I do the bend test, see, comes back, gives a little flex, so it does have a lot of strength. And the reason why I print out two is just in case if this broke. This one right here is just plain ASA filament. It's kind of like ABS. And I think this might be the closest material to the main gear, the original gear from Flywing produces, because usually a lot of plastics are made in ABS. But I can't confirm or that from Flywing. That's something I have to ask. Or if they comment on this, they can tell you. But overall, lost my train of thought. It's good. I like it. And I'm going to test it on the Bell 206, because the Bell 206, out of all my helicopters, has hardly any issues. And it also will be able to test the heat, because there's no air intakes. Like the windows are not cut out or anything. So it's all trapped in there, and it's going to produce a little bit more heat, including the frictional heat, which I want to test to make sure that this piece does not warp at all. So that is the test, and hopefully we could fly this for maybe a couple flights. And if it passes with no issues, no plastic remnants of like shavings or anything on the metal of the gear, on the motor side, we can say, hey, this is a very good substitute. The carbon fiber actually does help and gives it strength, which we saw on the computer with their impact and all their little testing. So yeah, so stay tuned for that video. And if you like and subscribe to this intro to this video, or if you have any questions, leave a comment down there. And if you want me to add a little bit more detail on certain prints style, leave that in the comments too. I just got this free print off of online. And it's also on the Flywing Facebook group too. And the creator, a huge shout out to you. Thank you for making this part or designing it, because this comes in a pinch when the main part is sold out and you really want to fly. This is a good alternative, but I don't know if it's cost effective too. If you don't have a 3D printer, everything, you're going to spend more money getting into 3D printing than just buying this $3 piece. So just keep that in mind. This is just here. How I look at this piece is when they discontinue this piece and they have another gear design. If you remember from the V1s, it was that white one. Now you can't find it. Like Mahui Gen 1 has it. But luckily, I think I can convert it to this gear just fine. But now all the new Flywing helicopters have this new gear. So, and it's nice that be able to 3D print this, I can fly for many years to come. And that's what it's there for. But let's just hope this PETG carbon fiber works out. I do have more filament we're gonna test into the higher tier. I think the next one's gonna be ABS carbon fiber, or no, glass fiber. So that would probably be the next one. And I also have ASA carbon fiber. I have PA6 carbon fiber and glass. I have PET carbon fiber, which is a very high temperature filament, really strong filament actually. And then I have PAH high temperature filament, which is used into like car engines and stuff. So we got a lot of different filaments we're gonna test for the heat. And I think a lot of these gears filaments are gonna pass, but stay tuned for those videos. So like and subscribe to the channel and have a great one.